In the last video, we learned how to solve simultaneous equations by using two different methods. The first was substitution, and the second was the method of elimination. And to recap, in substitution, we're going to take our two equations that have two variables, and let's just try use a new example here. X plus y is equal to 8, and 3x plus 2y is equal to 21. So we can see here that we have two variables and we have two equations. And in substitution, what we did was we rearranged one of our equations so that we isolated for one variable. For example, we could move this y to this side of the equation. Now we've isolated for x, and we have x is equal to 8 minus y. And then we would plug in that value for x into a different equation and then solve for our single variable. And once we get that value, we can plug in that value for our first variable into either of our two equations to solve for our second variable. Whereas in elimination, we either added or subtracted both in order to cancel out one of our variables, solve for our single variable, and then plug in that value for our single variable into either one of our equations and solve for our second variable. And now let's look at this example and try to actually use both substitution and elimination and see that no matter what method that we use, we're going to get to the same answer. So let's start out with using elimination for this example. And the first thing that I can notice is that if we were to actually multiply this top equation by 3, we would get 3x plus 3y is equal to 24. And then if we subtracted these two, we could cancel out our 3x's. So let's actually do that. Let's multiply this equation by 3. So that would give us 3x plus 3y is equal to 24. And now we have our second equation, which is 3x plus 2y is equal to 21. And what we can do is we can subtract these two. So 3x minus 3x is going to be equal to 0. 3y minus 2y is going to be equal to y. And 24 minus 21 is going to be equal to 3. So already we have y is equal to 3, and we have our value for our first variable. Now what we can do is we can plug in this value for y into either of our equations and solve for x. So let's use this equation up here. Let's put in 3 for y, so we have x plus 3 is equal to 8. That's going to be x is equal to 8 minus 3, which is equal to 5. So just like that, we have a value for x and we have a value for y. Now on the other side, let's try and use the method of substitution and see if we get the same answers. So these are our two equations, x plus y equals 8 and 3x plus 2y is equal to 21. So let me just rewrite those right here. X plus y is equal to 8 and 3x plus 2y is equal to 21. And now we're going to use the method of substitution. So what we can do is let's rewrite this in terms of only one of our variables. So let's isolate for x. We would get x is equal to 8 minus y because we brought this plus y to this side of the equation. And now we have isolated for x. So let's plug in this value for x into our second equation. And we would get 3 times 8 minus y plus 2y is equal to 21. And now we can solve this just like any other linear equation. So let's expand this out. 3 times 8 is equal to 24 minus 3y plus 2y is equal to 21. And if we move this 24 to this side of the equation and keep these two here, minus 3 plus 2 is going to be equal to minus y. That's going to be equal to 21 minus 24, which is minus 3. And so if we switch these two, we're going to get that y is equal to 3. And that is exactly what we got when we used the method of elimination over here. And now let's use this and solve for x. So now let's plug in y is equal to 3 into our other equation, which is this equation right here. And we're actually going to get exactly the same thing that we did here because we're plugging in this value into the same equation. So we're going to get that x plus y, and y is equal to 3, so x plus 3 is equal to 8. We can move this 3 to this side, and we're going to get x is equal to 8 minus 3, and that is x is equal to 5. So we can see that when we used elimination over here, we got y is equal to 3 and x is equal to 5, and we used substitution here and got the same answers. So you can use either of these two methods to solve simultaneous equations, and the method that you use is just going to depend on the type of equations that you get and whichever method is going to be the easiest for you. Let's go over another example. Let's say you were given the following two equations. 2 over x plus 1 over y is equal to 5. And the second equation, 2 over x minus 1 over y is equal to 2. So these are your two equations. And now you have to try and solve for both of our variables. So immediately the method that actually sticks out to me in this case is going to be elimination, and that's because we have a plus 1 over y here and a minus 1 over y here. So if we were to add these two together, we could cancel out our y and then solve for x. So let's actually do that. 2 over x plus 1 over y is equal to 5. And then 2 over x minus 1 over y is equal to 2. And we are going to be adding these two together. So 2 over x plus 2 over x is equal to 4 over x, plus 1 over y minus 1 over y is equal to 0. So we're going to have plus 0 here. And 5 plus 2 is equal to 7. So now we have 4 over x is equal to 7. And if we multiply both sides by x, so let's multiply this side by x and multiply this side by x, we're going to get 4 is equal to 7x. And we can isolate for x by dividing both sides by 7. So we're going to get that x is equal to 4 over 7. So we have that our x is equal to 4 over 7. But remember that we need to add a caveat here, and that caveat is that x cannot be equal to 0, obviously, because if we were to be dividing by 0, that would be undefined. So it's important to just note here that x cannot be equal to 0. And now let's use this value for x is equal to 4 over 7, to solve for y. So let's put that into either of our two equations. So let's just use this one. So 2 over 4 over 7, that's the same thing as 14 over 4. So we have 14 over 4 minus 1 over y is equal to 2. So let's take this minus 1 over y to this side and bring this 2 to this side. So we would have 14 over 4 minus 2 is equal to 1 over y. So we can rewrite this 2 as 8 over 4. So we would have 14 over 4 minus 8 over 4, that can be simplified to 2, is equal to 1 over y. We would get 6 over 4 is equal to 1 over y. And if we give ourselves a little bit more space, that means that y is just the reciprocal of this. So y is equal to 4 over 6, and that can be simplified to 2/3. And so we have our value for x, which is 4 over 7, and we have our value for y, which is 2/3. And we also have to remember here that y cannot be equal to 0.